All right, today we are going to be using synthetic division again. We've already done this before, so this should be familiar to you. We're going to be determining if linear expressions are factors. And a linear expression, as you can see here, x plus 1, it's like y equals mx plus b, basically where the exponent here is a 1. Okay, so how do we do that? I'm going to show you right now. So when you're looking at synthetic division, if you remember back, you take the x plus 1, set it equals 0, then you subtract 1, cancel those, and x is equal to negative 1. And then that's when you would go into the synthetic division. So pretty much, when you don't have a number out here in front of x, you can just take that number and do the opposite. So it's a positive 1 that turns it into a negative 1. Then you look at your exponents and see if it counts down perfectly. 4, 3, 2, 1, and then a constant. It does. And so we just write the coefficients down. 2, 2, a 1, a negative 1, and a negative 1. And then it's asking to determine if this is a factor. We know that's a factor if this equals 0 right here. If it doesn't, then no, it's not a factor. And so let's see. Remember, this drops down, and then that times that is negative 2, and then these, you combine them or add them together. So a 2 plus a negative 2 would be a 0. And then again, you multiply here, so that would be a 0. That 1 would come down. Once you add that, that would become a negative 1. Then negative 1 plus another negative 1 is a negative 2. And then a negative 1 times a negative 2 is a 2. And you end up having a positive 1 in here. And so all this is asking on these is determine if it's a factor or not. And so in this case, no are not a factor. Okay. So once we see that that's greater than 0 or anything other than 0, then we know it's not a factor. So now we can move on to number 2. All right, so we'll set up here. That's a negative 1 there, so we have a positive 1 here. Our exponents, 4, 3, 2, 1, and then a constant. So we know we can use all the numbers that are there. 1, 2, negative 5, 3, and a negative 1. Remember, your box goes here. This automatically comes down. And then we can just do our math. So negative 5 plus 3 is negative 2. Negative 2 times 1 is negative 2. That becomes a positive 1. 1 times 1 is 0. And so to answer this question, yes, a factor, because that is equal to 0. So these first 4 are pretty much the same. Well, number 4 is a little bit different. We'll talk about that. So pause it and try number 3 by yourself and then come back. All right, so hopefully that was enough time for you to try it. Now let's see if you were correct. This is a negative 3, so we're going to use a positive 3 over here. This, 3, 2, 1, and then a constant, so we know we can use our coefficients. 1, negative 4, negative 9, and 36. This comes down. 3 times 1 is 3. Negative 4 plus 3 is a negative 1. Negative 1 times 3 is negative 3. That adds together to be a negative 12. 3 times a negative 12 is a negative 36. That's a 0. So, yes, a factor. Okay, so looking at number 4, No difference here. This is a little bit less. That's because there's a little bit less terms in there because it's not counting down perfectly. So there's a 3, but there's no 2, right? And so wherever we're missing an exponent to count down, then we have to put a 0 in its place. This is all review. So it's a positive, our negative 5 here. So over here, we're going to make it a positive 5. And so we have a 2, but there is no x. We're putting a 2 because that's there. There's no x to the second, so we have to put a 0 in that place. We do have an x to the first, so we can use the negative 45, and then we have our constant of a negative 7. And then we go from there. So 2 drops down, comes 10, because 5 times 2 is 10. That 10 drops down. This becomes a 50. 5 comes down. 5 times 5 is 25. A negative 7 plus a 25 is an 18. That's not a 0. It's not equal to 0, so not a factor. So, to summarize, if it's saying to use synthetic division and determine if it's a factor, it's asking you if this right here that you're being divided by, is that a factor? If this is not 0, then it's not a factor. If it is 0, then it is a factor. So 0, it's a factor. 0 here, it's a factor. 18 there, not a factor. Okay, going on to number 5 and 6, 7, and 8. So now it's asking us to find all the factors of the polynomial. Okay, and so we're using this. This is the same thing as like dividing by this. So it's the exact same process. So we'd set x minus 5 equals 0. Add 5 to both sides. X is be equal to 5. So same thing, opposite of what was there. So 5. And then is this counting down? 3, 2, 1, and then a constant. It is. So we use what's there. So we're going beyond if it's a factor. We want to know all the factors. That comes down. 5 times 1 is 5. Add that together, it's an 8. 5 times 8 is 40. Add that together, becomes 15. 5 times 15 is 75. That equals 0. Now remember, your degree is always going to be 1 less than this. So we know we'd have x to the second, x to the first, and then no x. Or we can just count backwards. X to the 0, x to the first, x to the second. So x to the 0, x to the first, x to the second. So we know we're left with x squared plus 8x and plus a positive 15. Now, we want to know the factors, and so of course we have to factor that. So we'll come out with the x factor. This times that is 15. So we're just using that number there. Then the 8, the b term always goes on the bottom. Two numbers that multiply to give you 15 and add up to give you 8 are combined together to give you 8. You got a 3 and a 5. And so my factors are x plus 3, x plus 5, and that's 2 of the zeros, right? Once we solve for those. So, but we know it started with a to the third power cubed. So, where's the third factor? The third factor is what we started with, because remember, if we can do the synthetic division and we have a remainder of 0, that means that's also a factor. So we started with one of the factors, which is going to be our third factor, which is x minus 5. So all my factors are right here. 3 factors, highest exponent of 3. All right, might not get that right out the gate, But as we continue moving, hopefully you'll get it. And to check that, let's look at number 6. So we're doing the same process. We're taking, oops, I meant to use a pointer. We're taking this x plus 1, set that equal to 0 and solve. That would give us a negative 1. Is this counting down? 3, 2, 1, and then a constant? Yes, it is. So we're using the coefficients. And so essentially what we're doing here is checking if this x plus 1 is a factor. And so let's do our math. First one automatically drops down. Multiply. It's a negative 1. No, that's not a negative 1. What am I talking about? You can tell it's late. Another late night video. A negative 1 times 2 would be a negative, go back to red ink, negative 2. Yeah, that's right. So then that 1 minus 2 is a negative 1. Negative 1 times negative 1 is a positive 1. That leaves us with another negative 1 there. Negative 1 times a negative 1 becomes a positive 1, and that's a 0. Let's write a better 0. Okay. So that tells us that this, in fact, is one of the factors. So x plus 1 is a factor. Let's get to factoring the rest here. So x to the 0, x to the first power, x to the second power. So we have 2x squared minus x minus 1. Now let's go ahead and factor. We got negative 1 times 2 is a negative 2. And a negative 1 at the bottom. So we have a 2, negative 2, and a positive 1. If you multiply negative 2 times 1, that gives you negative 2. And if you take a negative 2 plus 1, it gives you negative 1. And so that would leave you with x minus 2, x plus 1. Then we multiply it by a number out here in front, so we have to divide back out. So that would be divided by 2, divided by 2. This one simplifies to x minus 1. This one does not simplify. It's already in the simplest form of 1 over 2. Can't leave it as a fraction, so we go ahead and pull this up front. Remember, bottoms up. So that becomes 2x plus 1. So our factors are, we started with x plus 1. Then we have x minus 1. And then 2x plus 1. These are our factors. All right, try number 7 by yourself. Pause the video and give it a shot. Really actually do this. All right, try that out yourself, and then we'll come back. So pause the video and try it. All right, I'd be interested to see how that went for you. This is a little bit different. So we take that, set it equal to 0 and solve it. That would give us a negative 1. And then does this count down? 4, 3, 2, 1. Constant, yes it does. So we have a 1 there, negative 2, negative 7, an 8, and a 12. Then that drops. Negative 1 times 1 is a negative 1. Becomes a negative 3. Then that becomes a positive 3 after you multiply. So negative 4. Negative 1 times negative 4 is a positive 4. Becomes a 12. Negative 1 times 12 is a negative 12. That's a 0. And so we know, yes, this is a factor. So that's one of our factors. I might as well put it down now, right? So factors x plus 1. How many factors should we have? 4, right? Because that is a 4 right there, highest exponent. All right, so what's next? Put our x's in there so we can count backwards. X to the 0, x to the 1, x to the 2, x to the 3. So we have x cubed minus 3x squared minus 4x plus 12. Now, this is a little bit different because it's not a quadratic, it's not an x squared. But if you remember factor by grouping, you can factor by grouping, or you can use that calculator trick that I gave you to find the zeros, but then you'd have to work backwards. And so we're going to factor by grouping. So to factor by grouping, we group the first set, group the second set, then we look for the GCF. This is a 1 here, so we know we're not going to pull out a 1, so we look at our letters. Smallest exponent wins, and so we pull out a x squared, and then what goes inside? Well, you can take your GCF and divide it by the terms in there. So when you do that, divided by x squared, divided by x squared, take that 3, subtract a 2, that leaves you with an x. Then you have a negative 3, and then the 2 minus 2 is 0. So that's what we're left with. Oh, go back. All right. So we know if we did that right, this also has to be x minus 3. So you ask yourself, what do you have to multiply an x by to get a negative 4x? That answer would be a negative 4. Then you combine what's outside the parentheses into a set of parentheses, x cubed minus 4. Let's use a different color ink. X cubed minus 4, and then you condense the like parentheses down to 1. And so we know that there's nothing that can be done with this, so we know that's one of our factors. But this right here is a difference of 2 squares. How do you solve that? Take the square root of that, which would be x. Square root of that would be 2. So we know that would be x plus 2, x minus 2, because when you solve with a radical, it's always going to be plus or minus. A negative 2 times a negative 2 is a positive 4, and a positive 2 times a positive 2 is a positive 4, and so it's always plus or minus. So x plus 2, x minus 2. And those are your factors. Highest exponent of 4, 4 factors. Excuse me. Let's look at number 4. We could do this with synthetic divisions with a lot of zeros in there, or we could recognize that this is the difference of 2 squares. If you have an even exponent, then that is a perfect square. So if this was a 6, if it was an 8, it'd be a perfect square. 16 here, that's a perfect square. So how do you solve a perfect square? Well, anytime you take the square root, it takes 2 off of the exponents. And so square root. If I take 2 off of that 4, that would leave me with an x squared. Square root of that 16 is a 4. And if we're doing the, the difference of 2 squares, it's got to be a positive and a negative. So an x squared plus 4 and an x squared minus 4. We already know that this is going to be one of the factors. And so let's go ahead and write it out here. Factors. How do we know that? How do we know that? We'd have to do synthetic division to know that for sure. So Shall we walk through that? We'll do that at the end. All right, and so we have an x squared. Let's look at this one first. An x squared minus 4. That is the difference of two squares, and so we solve by square root. Not solve by square root, but you take a square root there, take a square root there. That will leave you with x plus 2 and an x minus 2. And then you do the same thing here. Now there's a difference though. This is the sum of two squares. Remember we talked about that early on in the semester. When you have a sum of two squares, you have to add an I in there. So x plus 2i and x minus 2i. So actually, we don't have to do the synthetic on this one because that x plus 2, when we do it this way, we see that x plus 2 is in fact one of the factors, and so we don't have to do the synthetic division, solving it this way. So x plus 2, x minus 2, x plus 2i, x minus 2i. And so those are all of our factors. So let's, I guess we can just do this. All right. If you don't get that, watch it back. Actually, I'll do a recap. We looked here, we saw that this is a perfect square. 4 times 4 is 16. Okay. If your exponent is even here, then you can have then it is a perfect square. And so when you take the square root of something, square root is the opposite of a square, and so that takes 2 off of the exponent, that's why we had an x squared here. So difference of squares, remember we're going to have one positive one and one negative one. So x squared plus 4, x squared minus 4. Then we look again, we have another difference of two squares, so we can factor out more. Do the exact same thing. That leaves us with x plus 2, x minus 2. And then only difference here with the sum of squares, sum of two squares, like we've already learned, is you got to add the I in there. X plus 2i, x minus 2i. Hopefully that made sense. Let's move on to number 9. All right, it says, given one factor of the polynomial, find all the zeros, and then draw a rough sketch of that. Oh, I'm tired. So, excuse me. Let's go ahead and do synthetic division. All right, so that's an x plus 1, so we know we're going to be using a negative 1 there. Does this count down? 3, 2, 1, and then a constant it does, and so we use the coefficients as they are with no zeros. Oops. So 1, negative 7, negative 6. Don't like that. Negative 6. All right, and then on to synthetic division. Drop that down automatically. 2 times a negative 1 is a negative 2. It's negative 1. Positive 1, negative 6. Negative 1 times a negative 6 is a 6. That's a 0. Remember, count backwards from, or we can just know that we take 1 off the exponent, so that's 2, 1. Or count backwards, x to the 0, x to the first, x to the second. Rewrite it, 2x squared minus x minus 6. We see that this is a 0, so we know that this is in fact a factor. So one of the factors is x plus 1. Now we factor to get the remaining factors, right? So 2 times negative 6 is negative 12, and a negative 1. Two numbers that multiply to give me a negative 12, but then add or subtract to give me a negative 1 is a 3 and a negative 4. If I write that out, it's x plus 3, x minus 4. I multiplied by 2, so I got to divide by 2 to get that 2 back out of there. Does this simplify? No, it doesn't. So bottoms up. That would be 2x plus 3. And then that one does simplify down to x minus 2. And then if I bring my other factors down with it, or my other factor, this one, then I have all my factors. But this is wanting me to graph, and it's saying find all the zeros. Oops, pointer. Find all these zeros. So how do we do that? We set all of these equal to 0 and solve them. So let's start with the first one. 2x plus 3 is equal to 0. And that would be, subtract 3 on that side, subtract 3 on that side. That cancels. 2x is equal to negative 3. And then we want to divide by 2, divide by 2. X would be equal to negative 3 over 2. So that is one of my zeros. Do the same thing for the other two. So x minus 2 is equal to 0. This is a one-stepper. Plus 2 plus 2. That cancels. X is equal to 2. There's another one of my zeros. And the last one is x plus 1 is equal to 0. Subtract 1, subtract 1. Cancels. X is equal to negative 1. So I got 3 zeros. Highest exponent of 3. Now, all we got to do is graph them. This is an odd function. There's no negative there, and so we know, going back to stuff we've already learned, that's a left side down and a right side up. So let's get our points. First point is easy to plot. That is a 2, positive 2. So x-intercept at positive 2. Then we got 1 at negative 1. And then we have 1 at negative 3 over 2. And so how do you figure out what that is? Well, all you do is go on your calculator and type in negative 3 over 2, and you hit enter, and then you toggle back to see what the decimal is, and that would give you a negative 1.5. So where is negative 1.5? Negative 1.5 is directly between negative 1 and negative 2. So it'll be somewhere, let's make these points a little bit smaller so it's easier to graph. I'll change the color. So again, a point at 2 in red, a point at negative 1, and a point at negative 1.5. So we talked about it a second ago. We know we're going to have left side down, right side up. Sorry, my allergies are kind of going a little crazy. So left side down, right side up. We also know from the past that the constant is our y-intercept. And so you know what? We have one at negative 6. So we can put negative 6 there. And so we know that that's got to be coming out of there to connect here. Means this is going up, coming back down, going back through there, and that's roughly what your graph looks like. So let me make the ink a little thicker so you can see it. Just a rough sketch. There it is. Now, if you were to go into your table from the jump and put this in, it probably would have gave you, well, it definitely would have gave you these 2 zeros. You wouldn't have known the third one. It wouldn't have given you this one. But you would have had 2 of the zeros to work with. But it would have given you some other points where you probably still could have mustered up some type of legible graph. And we'll talk about that another time. Let's move on to, is this the last one? Yes, it is indeed the last one. All right, and so we're doing the exact same thing. try this one yourself. Give yourself a challenge. Try to go through all the steps and graph it. Obviously, you need the zeros, which on this one, you can't get all of them out of the calculator. You can get some points that can help you graph, but it's not going to be all of the zeros. Because I'm looking at the key right here, and they're not all whole numbers. Some of them are fractions, or one of them is a fraction. So let's get to it. Last one. So set this equal to 0 and solve it. That becomes a -4. Does this count down? 3, 2, 1. It does. So 3, 2, oops. -37. Now a 12. Always put my box there for the remainder. -12. -10. Oops, should be a +40. Oops. 3. -12. 0. So we know that that is a factor. So count backwards. X to the 0, x to the first, x to the second. That leaves us with 3x squared minus 10x plus 3. Now we have to factor. This times this is 9. So 9. B term always goes here. Two numbers that multiply to give me 9, and then add together to give me, add or subtract to give me a 10. It's got to be 9 and 1, right? So I got a -9 and a -1. -9 times -1 is a +9. -9 plus a -1 is -10. So we have x minus 9, x minus 1. We multiply by this 3 here, so we have to divide back out. Divide by 3, divide by 3. This simplifies down to x minus 3. This does not simplify. It's already down to the simplest form, -1/3. So bottoms up. Slide the 3 in front. Then our other factor that we already identified is x plus 4. We set these all equal to 0 and solve them. We know that this is going to become a x is equal to a +3. We know this is going to be x is equal to a -4. And then we got to set this equal to 0 and solve it. I know that that's going to be a +1/3, but you'll see. +1 plus 1, that cancels, leaving 3x is equal to 1. Divide by 3, divide by 3, cancels, x is equal to 1/3. So now we have points that we can plot. We have 3 of them, which makes sense because we have a highest exponent of 3 there. So the first one, easy to plot. We have a 3. Then we have a -4. And then we have a +1/3. Again, if you don't know what that is, you just go in your calculator, type a 1/3, toggle it, and that'll give you a .33, +0.33. That's a little bit less than half, and so we'll plot that on there, right there. This is an odd function, so we know left side should be down, right side should be up, with going up 1, down 2, up 3, so we know our graph should look something similar to this. So left side down. What's our y-intercept? Our y-intercept is 12, because that's our constant, so we know we have a point there. And so we know that that's going to be doing something like that, coming back down, and then right side back up. So we know we have a graph that looks something like that. All right. That's it for the day. So submit your notes and have a good rest of the day.